Hey everyone, it's Jim
And Charles
from Mellow amps. And we're going to finally start soldering. But let's go over a couple of key things before we start. First of all, solder fumes can be hazardous to your health, so make sure you have good ventilation. So working near a window that is open is a very good thing. I actually use on my bench when I'm doing a lot of soldering work, I have a little tiny USB fan that I blow across. Now I don't put it anywhere near the actual solder work, or it'll cool off the soldering iron and it'll muck up your work. So I have it about a meter to my right. It could be on your left or wherever it makes sense. That really helps to keep the fumes away from, my breathing.
The solder also contains lead too, so make sure you wash your hands after handling it.
Yeah. So, and of course, soldering irons are a heat and a fire hazard. We highly recommend you use an auto shut-off soldering iron, and get into the habit of checking to make sure that you've put your soldering iron back in the holder properly. This is one of the things that I constantly don't do, and it's dangerous. Work on a low flammability or flame-proof surface. That's also very good. And just work safely and methodically and carefully.
Don't do it while distracted or running and cooking dinner or something like that.
Yeah. Now, and if you're not 100% sure about soldering or your soldering skills, there's a link below to how-to videos that we've done over the years. There's a whole series of them, and they'll help you, with everything to do with soldering. We like to apply a little tiny bit of solder flux to our work as we go, and we'll show you, and a very, very, very small amount, or you'll have a mucky mess on your board. So you'll watch us work on the first few components, and you'll get sort of a sense of our preferred work method. What else, Charles? Oh, and if you would like to do some
practice.
Yeah, there's also a link below. For $1, you can buy a scrap practice PCB and some components, and get your soldering up to speed, because the last thing in the world you want to do is to make a muck up of the board and have cold solder joints all over the place. Soldering is not hard to do, but getting from zero to soldering competently takes a little bit of practice and a little bit of knowledge. So the videos will help, a little practicing will help. Okay, enough yammering, let's get going. Best practice is to start with small components. You might notice that we're mounted in the S2 build stands. These just make life so much easier. I highly recommend them. They're not expensive. They're in the store. Just scroll down below the kits and you'll see the accessories. Okay, so diodes, of course, take the AC that comes in from your wall and transform it into a very raw DC, which we have to filter. But let's get the diodes in first before we worry about the filtering. And they're banded. So there's an anode and a cathode. And you can see there's a white band. That's the negative side or cathode of the diode. And you can see that the band is clearly marked on the board. The component position, which side, this is a double-sided or dual-sided board. Let me just flip it over for you. So you can see you could actually mount the diodes here somehow if you could figure out where they went, but obviously they go on the side where the component is marked.
And of course the line on the diode lines up with the line on the mark.
Yeah. Okay, so the first thing you want to do is just figure out roughly where you'd like to bend your lead. We like to use a little spudger. A little bamboo skewer will work just perfectly as well.
Don't bend these hard right on the edge of the diode, because you can easily damage the diode that way. Make sure the bend comes off on a nice curve out from the side.
And then once you get the right, the bend correct, we're going to drop them in. And if you didn't quite get it right, don't be afraid to come in and just clean it up a little bit. So we're going to show you, periodically we'll show you how to fix things so that you get a nice, neat, good job.
And this is just part of building here. Even with experience, we have to come back in and fix leads after we've already bent them. It's just a normal thing to do.
Now, good practice for anything that can get hot or damaged by heat is to space your component off the board. We're going to show you when that's necessary. Very small resistors, 1 watt below, really don't need that spacing. But something like a diode, yeah, it might actually improve the lifespan of the diode.
And we're only lifting it off just a little bit here.
So I'll show you. I have a whole set of little shims that are wood, so that.
But you can also use something like a toothpick or a wooden skewer.
Yeah, almost anything will do. And we're just going to get these in place. And again, look at this. This one fits perfectly. This one's just a little bit tight. So rather than force it, I'm going to come in here and I'm going to rework it.
You can't do this too many times or else you're going to break the lead off. But you can make 1 or 2 adjustments to it.
It's first thing in the morning here, so everybody's just waking up. And there we go. Okay, now we're going to call out your soldering temperatures. Soldering temperatures make a huge difference in how your solder flows. So I'll call out the temperature first in Celsius and then second in Fahrenheit, and I'll always let you know what I'm calling out.
Keep in mind though that every iron's going to be a little bit different. Some of them are going to be calibrated incorrectly. Some of them are going to have better performance at certain temperatures. So you'll get a feel for yours after a little bit of time. Maybe it's going to be a little bit lower or a little bit higher than what we're calling out.
Yeah, and the rule is if the solder is flowing too fast, it's basically not staying in place. Now, we want the tiniest little drop of flux. You really don't want to, I'm going to say this quite a few times during the build, you really don't want a lot of this. The only time that you need a lot, I'll tell you.
But yeah, if your solder is flowing too quickly, turn it down. If it's not flowing fast enough, turn it up. Pretty simple.
Yeah. And high quality solder makes a huge difference. Don't go cheap on your solder, and don't use really old solder. There's a very good chance it won't work well.
Or lead free. Yeah,
lead free is absolutely only for professionals who really know what they're doing. It's not easy to work with. I use a fairly large chisel tip because it can do a lot of work and I like to move fast. You probably work with something a little smaller, but chisel chips are awesome because they can do a lot of different kinds of jobs and they can get in. So
you want to bring the tip in so that it's touching both the pad and the lead with a little bit of solder on it, and then you feed in some more and let it flow down.
And then you hold for a second and you're off. So we were soldering at my standard center temperature for my iron is 460 C, which is roughly 870 Fahrenheit. Now, when you're soldering any electrical component, you want to scatter around the heat. So I'm not automatically going to go and do the other lead. I'm going to hop over to the other diode, and you can see how I just tested it with the solder. I hold for a second, I'm off. We're not going to do this for every single component. Having a clean tip. So here, let me just show you. This is just
a kitchen scrubber.
And it's an old kitchen scrubber. New ones don't work. But it's a stainless steel scrubber.
They also make brass ones and copper ones too that you can buy that are meant for the purpose.
And they work just fine. So I've got a little bit of solder on there to get it going. I'm going to hold for a second and I'm off. You don't have to re-tin your tip all the time. Once you get it going, it'll go for a while before it needs to be clean. I'm going to hold for a second and I'm off. Now, you heard that? I'm cleaning the tip. I'm constantly cleaning that tip. If it gets oxidized or full of junk,
it's hard to make a good connection and transfer that heat.
Okay, now let's go and take a look and see what we've accomplished. Now, we've got excellent flow through. These are...
I'm going to zoom right in here so they can see that a little better.
These are double-sided boards, and the actual pad goes right through the board.
And it's actually tinned all the way through.
So what happens when we have flow-through like this is we essentially have two pads on both sides of the board connecting up our electrical component. That's getting close to a mil-spec electrical job. We'll show you some other tips to get you to mil-spec or close to it. And we'll also show you what to do if you don't have full flow through. Now, I have full flow through, but I'll drop in here and just show you what to do. Okay, so it's not absolutely necessary to rework the other side of the board to make sure you have flow through, but it's a good idea. So with a clean tip, I'm going to put a little drop of solder on, and I'm just going to, now this is perfectly acceptable what's here, but I'm just going to show you what to do if you don't have full flow through. You just come in, heat up the pad and the solder, and just flow a little bit more solder in, and Bob's your uncle, you're off. Let me bring that over so that you can see a little bit better maybe. Okay, that's all there is to it.
So go ahead and take care of the other two diodes in the exact same way, and we'll see you back here in a second.
Okay, so we've got the 4 diodes in. We've included a spare diode. Occasionally we'll include bits of spare components, not always. Don't worry about it though. It's nice to have a spare diode. So just put it in your parts bin. And now, it's important that you carefully cut off the leads. These things are a real hazard underfoot and to your eyes. So if you're not wearing eye protection, and you should, hold the lead as you cut it after it cools off.
If it's in a tough spot, you can also hold it with a set of needle nose pliers.
I'm just going to do them all. We won't be showing trimming of leads again, I hope. This is about as boring as it gets. But it needs to be done. So you don't want to be snipping off too close to the board so that you actually cut off some of your solder. So don't be fussed if there's a tiny little nubbins left. That's pretty much perfect. And what do we need to do after we finish a component? We have to do 2 things. Okay. So the first thing to do is to verify that you've got the correct component in the right spot. And we're going to do that throughout the build. If we do this carefully, then the chances of having a build error at the end are just about 0. So we want to check the diode bands, and that these are correct and these are correct. Charles does a great job of laying out these PCBs, so it's really hard to make a mistake. So we've got our 4 diodes in. We want to go over to our parts list, and we want to find the diodes, and we want to actually check them off. So right there. And if you actually went through and checked off this list when you sorted your parts, you can do this. You can put a second check through.
Or just cross it out next to it or something.
Yeah, whatever you want.
Okay, so we're going to move on from here and do some of the other smaller components. But first, a warning here. We're going to start with the smaller resistors, but R5A and R5B we cannot do yet. So leave those until we tell you that it's time to put them in.
Yeah, otherwise you're going to get in the road of installing the RCA jacks. Okay, what's next? Okay, so next up is R6. And we've got 2 of them here on the parts list, and they are 220R, which is 220 ohm, right? R is just short for ohm. And we've got our volt to ohm meter set into the ohm function, and we're clipped on, and we're getting 221.3. remember these are plus or minus 1% metal films. Not all resistors are that. We've got some plus or minus 5% larger resistors later on, the power resistors. So their variance will be much higher. All the critical components in the kits have been already matched for you. If they're less critical, we just don't fuss with matching. So long as they're in the ballpark. But the main reason for putting your resistors on your ohm meter is to make sure you get the right resistor in the right spot. So be really careful about the difference between an ohm and a k-ohm. A k-ohm is 1,000 ohms. And a megohm, of course, is another 1,000 times that, which makes it a million ohms. Yeah.
Yeah, and we don't have anything here that I think is going to be too confusing, like on some other kits, especially in the same sizes. So you should be okay, but it's good to verify before you put the resistor in. It's one of the most common build errors.
Okay, so let's get our 6s on the board. Okay, so our 6s go here and here. You might notice we got an A and a B. The A is for one of the channels, and the B is for the other channel. And that's going to be typical throughout the board. So even though you see that you've got an R6, you actually have two R6s. And we're going to do the same thing as we did with the diodes. But I can see, and I'm just using one of my favorite tools, which is a bamboo knitting needle, actually. So in it goes like that. We're not going to show every single component. Now, small resistors don't need to be stood off the board. In fact, you don't want to. That's not going to help you. So we're going to just bend back the leads. And most small components are going to be soldered on at the same temperature, at least on my station.
Now you need to be a little bit careful here with this pin close to pin 1 because we don't have the socket in there yet, so you don't want to fill that up with solder. So just be careful not to add anything onto there.
So we're coming in at 460 C, which is about 870 Fahrenheit, and the procedure is exactly the same as when we put the diodes on. We just get a little bit of solder going, and it's flowing nicely. We fill, we hold, we release. You don't want to be sitting on any components, even pretty durable ones like resistors, for any big length of time with the heat. So you want to get in and get out fairly quickly, even though you're holding for, a half a second maybe.
If it's something that you're reworking and it's taking a bit of time, then give it a break and come back after it's cooled down a little bit.
And you can see we've got good flow through here. If we didn't, we'd come in and just touch that up lightly.
Okay, so go ahead and get the other R6 in, and then check it off on your sheet, and then we're going to move on to the next size up resistors.
Okay, up next is R1, which is a 470K bleeder resistor, and this just helps drain off any energy sitting in the capacitors after the power is turned off. It takes a long time to drain them down, but it's just basically a safety resistor.
Now, we've already checked the value of this one, so we know it's on spec. And we're going to get it installed. There is one other similarly sized resistor that we're going to do next, but we're going to get this one in first. And because of the size of the pad on the discharge point here, you're going to need to flow a little bit more solder on it.
Yeah, actually, let's just do that with everybody so that they can see, because that's an important point. Later on in the build, we'll show you how to use the discharge pad. It's a really important safety feature, and if your soldering tip's getting mucked up, get it cleaned so that you have a good bright surface. Now we're going to flow a fair amount of solder, hold for a second, and we're off. There, you see we've got a nice big pad of solder. It'll make for a very easy connection later on to discharge the amp. Okay, what's next, Charles?
Okay, well, we're going to do the same thing. Let's flip the board over with R8 over here, and this is the filament dropping resistor. So you should be able to take care of that on your own, and we'll see you back here in a second once you get it installed.
Okay, so we've got R1 installed, we've got R8 installed, and we already checked the value with our ohm meter before we installed each of them. That's why we do one at a time. That way you can't put the wrong resistor in the wrong spot. And everything is looking good. So well done, everyone. That gets the soldering started, and we're just going to keep on going until we got the board done, basically.
We'll see you in the next episode.